Welcome everybody. Today we're going to talk about dynamic lighting, realities, practicalities, and potential. This is Jen Nequita with H.E. Williams Lighting, and we are doing an AIA accredited course. After we have completed this course, you will be given a quiz, and then that will be registered with our company, and we will send your information to AIA. You will receive a certificate and credit for this course. Certificates of completion for both AIA members and non-AIA members are available and will be directly sent to you. Today, the course description, what we're going to talk about is dynamic lighting is also known as tunable, color changing, and circadian lighting, and is adopted and employed in current lighting designs. There are many studies showing the benefits of dynamic lighting in the built environment. Early adopters have seeded the market, and several lighting manufacturers now employ some level of dynamic lighting. This course is intended to explore what dynamic lighting is, how it works in commercial luminaires, how it is controlled, and where the lighting community is being directed by standards, regulations, and the voice of the customer. We have 4 learning objectives that we'll be covering today. So at the end of the course, participants will learn, they'll be able to define elements of dynamic lighting. Participants will learn the uses of dynamic lighting. Participants will see illustrations of how to control dynamic lighting, and you'll be able to become aware of regulations, standards, and customer requests that are driving adoption. So let's dive into the first learning objective, define elements of dynamic lighting. What is dynamic lighting? Simply put, dynamic lighting is a light or group of lights with the ability to alter their color in response to some control input. This color change can span the entirety of the visible spectrum, the various colors of white light, color temperature specifically, along a black body curve, or just a specific set of colors. There are 4 types of dynamic lighting, and we're going to talk about each of those 4 types. Dim to warm, tunable white, tunable color, and biophilic lighting. In today's presentation, we're going to be building an understanding of these 4 dynamic lighting types. But first, what I want to do is I want to talk about the components that are unique to a dynamic lighting luminaire. The anatomy of a dynamic luminaire. So as you know, with an LED luminaire, you have your heat sinking, you have your fixture housing, you have your PCB circuit boards, your LED lighting array, your lens or optics and diffuser, and then you have some sort of controls. And when we talk about and start looking at each of the 4 types of dynamic lighting, we'll actually take it back to the different pieces that are entailed in the anatomy of a luminaire. First, we're going to start with the LED light source. Non-dynamic lighting has a fixed color temperature, CRI, or spectral power distribution. What makes dynamic lighting different than non-dynamic is the fact that we mix multiple LEDs of different colors, different color temperatures, different color rendering indexes, or different spectral distributions to create a specific light output. Most lighting designs today are implementing static color lighting solutions. This is where the lighting has a fixed color temperature, color rendering index. Since designers may include color lighting into their designs to give the spaces interest or to tell a story. But it is fair to say the majority of designs are specified with a standard color temperature like 3000 Kelvin to 3500 Kelvin for schools or class 2 office spaces, or color rendering index, a special color rendering index if you think of a grocery store to make meats and fruits really pop. With dynamic lighting, the number of LEDs of multiple colors, CCTs, CRIs, or SPDs are mixed together to create a specific light output. By doing this, it gives lighting designers another tool to use in their toolbox. Before we go any further, it's probably good to stop and talk about basic color theory with reference to lighting. When you were in art class in grade school, the mixing tempera paint together, what were the primary colors? As you can see, it's red, yellow, and blue. RYB, an abbreviation for red, yellow, and blue, is historic set of colors used in subtractive color mixing and is one commonly used set of primary colors. It is primarily used in art and design education, primarily painting, and it predates modern scientific color theory, which has determined that cyan, magenta, and yellow are the best set of 3 colorants to combine for the widest range of high chroma colors. With light, the primary colors for mixing are red, green, and blue, and depending on the intensity of each of the primary colors yields the actual color of the light. In LEDs, there are 2 ways to get white light: 100% red, 100% green, and 100% blue, or phosphor coating a blue LED chip. When you phosphor coat a blue LED chip, you are locked into a particular white color temperature, or CRI, based on the phosphor properties in the coating. So a light moves from a static light source to a dynamic light source with the use of combination of multiple color LEDs and or LEDs with different CCT, CRI, SBD, all mixed together. As designers, you can see this gives you another tool to use in your toolbox. Now let's take a look at other elements which make up a dynamic lighting luminaire, and in the subsequent slides, we'll explain each. This is a system overview. We start with the power conversion, which is either building line voltage at 120 or 277 volts, and we need to be able to convert the power to 12 volt up to 48 volts. Basically what's happening is, as you know, in an LED luminaire, you have a driver that takes building line voltage power and converts it into DC power, which is what inherently runs LEDs and makes them light. The control source is a source of the dynamic setting, typically a program running on a server or an intelligent room controller. With the mix of 2, that goes into a signal conversion, which interprets the dynamic setting request, specific color temperature, or CCT, translates that request into a drive current for the LEDs and provides the controlled drive current to the LED. Then you have the LEDs that is accepting that signal and lights. After the LED, you have the mixing chamber, which is common for dynamic fixtures to ensure proper color combining. With LEDs, as you know, LEDs are a point source and throw light in a certain direction. The importance of the color chamber is if you have a lot of LEDs on a board, all pointing in one direction, then the mixing chamber gives the opportunity for the light to be able to mix before it exits the luminaire. We'll look at that here a little bit closer in a minute. Optics, lensing, at the bottom of the light fixture luminaire, creates shapes and diffuses the light exiting the fixture. So now we're going to take a look at each one of those system pieces and talk a little bit more in depth regarding them. For the power conversion, there's 2 ways or 2 strategies to be able to do power conversion. For all fixtures, there is a device taking a generic power supply, which is your AC line voltage or DC line voltage, and converts it into a typically lower constant current or voltage in order to power the LEDs. In both examples shown below on this slide, the power conversion device is providing a direct control of the LEDs depicted by the green arrows. So the top example is a node. It's an electronic node that basically has an input of DC power and has an output of DC power to the LEDs. Most of you are probably familiar with the bottom one, where it is the driver taking the AC current from the building system and converting it into DC so that it can light the LEDs. Fixture manufacturers use a device called an LED driver or a node, which takes the line voltage present and converts it to a voltage which directly controls the LEDs. This configuration typically used when there is a single point of control, such as dimming or color changing. Where there is multiple color points, if you want to dim and color change, a power and control signal is required to create dynamic lighting. A signal converter at the fixture is required to interpret and execute the control commands. Signal converters can be a single device which does power conversion and signal interpretation, and that's the top configuration. A signal converter at the fixture is required to interpret and execute the control commands. The signal converter can either be a single device or it can be two tandem devices which perform each function, one performing the power conversion function and the other performing the signal interpretation. The mixing chamber optics and lensing. We've already talked extensively about the LEDs. As you know, LEDs are considered a point source, throwing light in one direction. In dynamic lighting luminaires, manufacturers use some sort of mixing chamber, optical system, and/or lensing to create smooth, uniform light emitted from the luminaire. A mixing chamber is always required to make sure all of the colors of the light are properly mixed. Optical systems such as TIRs or lenses can be added either before or after the mixing chamber and can bookend the mixing chamber to get optimal color mixing results. Now that you understand all of the elements needed for a dynamic lighting luminaire, let's break down the 4 types of dynamic lighting. Just to remind you, the 4 types are dim to warm, tunable white, tunable color, and biophilic lighting. What we're going to do is we're going to look at the definition, then we're going to look at applications and usage, and then we're going to look at control strategies. Types of dynamic lighting on the dim to warm side. The simplest form of dynamic lighting is dim to warm. This dynamic lighting strategy mimics the color shift of traditional sources, such as incandescent and halogen, when they are dimmed. This type of dynamic lighting is achieved by using 2 shades of white, LEDs, usually on opposite ends of the spectrum, like 3000 Kelvin and 5000 Kelvin, and changing the light intensity ratios to change shift, to color shift, and decreasing the lumen output. So at 100%, if you look at the slide, at 100% on the left-hand side, you have the brightest, and it's a cooler color temperature of light, if that's what you want to call it. It looks really warm in this picture. But as you dim down from left to right, as that light gets less intense, less light output, it warms up to be kind of a more warmer color temperature. Another type of white dynamic lighting is tunable white. With tunable white, the color of the light can be tuned in a specific color temperature range. How we do that is by doing either a 2-channel mixing, 3-channel mixing, or 5-channel mixing. By employing 2-channel or more colors of white LEDs mixed together, we can achieve various colors of white light. For example, 2-channel end of LED, you've got a 3000 Kelvin, 3500 Kelvin, and a 6500 Kelvin LED mixed together. This result gets a white light along the line, along this line. Then if you're doing 3-channel color mixing, you have 3 points. So basically you have 3 different types of white light modulating together through controls, and you can get anywhere, any color of white light within that triangle of the middle diagram. And then from 5 points channel, a 5-channel color mixing, basically what happens is you have a R chip, a red chip, and a green chip. And then you have a warm white and a cool white chip. So you have 5 different things, and you're modulating with your controls through all 5 of those to be able to create the most dynamic full spectrum output. There are more variants of white light LED chips used, the more precise resulting color of white achieved. And with the higher number of different LEDs comes an increased complexity in the control system needed to achieve the desired result. The third type of dynamic lighting is tunable color. This type is most commonly known by designers and is either referred to as RGB color changing or can be RGBW color changing. With tunable color, a designer can achieve any color in the visible spectrum of mixing intensity ratios of red, green, and blue. White light is achieved by mixing full intensity, 100% of red, green, and blue, and then mixing, when you have an RGBW system, you take and you clean the red, green, and blue white light up with a little bit of cool white or warm white, adding a ratio of white light to achieve resultant color of the light desired. Last but not least, the fourth type of dynamic lighting is biophilic lighting. Biophilic is sometimes referred to as circadian lighting, which is modified spectral distribution lighting or human-centric lighting. Basically, biophilic lighting uses tunable specific LEDs to replicate natural sunlight to trigger biological responses. For example, using a dynamic lighting system which increases or decreases wavelengths of light in a circadian or melantopic range at the right times can help regulate natural sleep patterns. To achieve biophilic lighting, LEDs with a fixed color temperature and variable SPD, or variable color temperature and fixed SPD, or fixed color temperature and fixed SPD. So with that, we've defined all 4 of the types of dynamic lighting. Learning objective 2. Next, we're going to learn the uses of dynamic lighting. Dim to warm. As previously stated, dim to warm replicates the color shift of incandescent and halogen lighting. Good application types of examples include personal workspaces, residential style, group living facilities, mood settings, evening occupied hospitality, restaurant, and hotel lobbies. There are probably many other applications that you can use this in, but these are some of the most common ones. Tunable white changes color temperature along the black body curve and the color temperature of white light, circadian rhythm. So use cases or application types for this type of dynamic lighting would be performance and corporate headquarters or cubicle areas, alertness, shift work in factories, hospitals or call centers, on-demand task focus, such as classrooms and lecture halls, and then personal preference in private offices, desk task lighting, tunable white can be used. I've even had an example where they used tunable white lighting in an airplane. Took an overseas trip from Los Angeles to Sydney, Australia, and about 2 hours before we landed, it was a 17-hour trip, and the lighting inside the plane came up tunable white, just like the sunrise would. And so I could feel within my body system how it was easier, even though I was jet lagged like crazy, it was easier to be able to awake to that versus just having the lights come right on and be starkly awakened. Tunable color is a full range of color spectrum. Hospitality and restaurants, hotel lobbies are examples of where to be used with this. Branding messaging is a possibility that you can use tunable color for. Business lobbies, retail after hours, business facades, mood setting in children's hospitals, coves in schools, hospitals, office corridors, events, office parties, guests, entertainments, convention centers. With tunable color, there's a wide range of possibilities to be able to pop a little color here, pop a little color there to be able to get some excitement or to get just a little bit of interest in a lighting design. And then tunable color can actually be used for beaconing, where you have direct view messaging using white or color. Types of examples of beaconing use would be security, where you change general illumination from white to a color. An example would be a school intruder. Safety, shift to color, where all or many of the lights, if you have a weather emergency, they may turn to an orange color or a different color to notify that something is going on. Wayfinding, color or pulse white light can direct visitors to a location in a school or an office. You could even use it in a hospital type setting where you walk in and the lights direct you to where you're wanting to go. And then space status, tunable color can be used for beaconing space status, like in meeting rooms or common areas where you put up a red or a green light. If it's green, nobody's occupying the space. If it's red, the space is being occupied. Then biophilic lighting is basically your SPD modified light sources. And the LEDs and modules with modified spectral power distribution precisely elicit biological responses. Same tunable white applications are addressed with this technology layered into the color temperature change. And then same tunable white applications are addressed by tuning the SPD and not this CCT. So one of the main differences between the biophilic lighting and your tunable white lighting is with tunable white, you're modulating the color temperature. With biophilic, you're actually modulating the spectral power distribution. Learning objective 3, we're going to see illustrations of how to control dynamic lighting. By its nature as a replication of incandescent dimming response, this option only utilizes standard dimming methods. So your dim to warm is the simplest, from a controls perspective, is the simplest dimming circuit. It can be a standalone system. It's a non-programmable system. Usually you take care of the control strategy via wall, power pack, or a dimming panel. So you have a wall station that may have some sort of 0 to 10 volt dimmer in it, or you may have a power pack that goes back to a dimming station. And then dim to warm is a standard single circuit output driver. With tunable white products offer a full range of color temperature selection to the project team. Controls are selected to deliver the right solution to the occupant. These options can be combined. For example, there are scheduled changes that can be overridden by local wall buttons. So there's 3 strategies to be able to control tunable white. You can either have it on a scheduled automatic system. You can have it on a manual system where it's task oriented. So like a conference room, you would have different scenes or open office space, or you can have it on a manual system that is just free flow. So if you think of a classroom where the teacher has complete control over what color temperature of light that they want in their space, or a personal office. Each application and occupant group may have different needs. They may have a specific color temperature range that they're interested in, or special wavelengths, or peak activity periods. So with the scheduled system, it can automatically run a variety of schedules to support the business. It can also run one schedule across an entire building in each room or even in each fixture. Typically, it utilizes a networked installation. So a tunable white is a little bit more sophisticated of a control system versus the dim to white. Tunable white from a manual perspective, occupant control, network or standalone system with or without a central control schedule. If it's a standalone system, likely you won't have it tied in to where it's automatically changing with a signal. It's a manual change. You go over to the wall station and hit the general button and the lights change. Task-oriented presets allow quick and precise lighting tailored to the application. And for ultimate freedom for the applicant, you basically can give an up-down manual color temperature or spectral power distribution control. And an example of that is the bottom left-hand slide. When we start getting into color, since tunable color is most likely either a 3-channel or 5-channel over the full visible spectrum, it has the widest range of color output options, and it also has the most sophisticated complex programming requirements. So that basically leads you into the most sophisticated control system. Basically the same control options for tunable color as tunable white. You can do scheduled, manual, networked, or standalone. It is substantially more complex content creation. Task-oriented presets allow quick and precise lighting tailored to the application. And then typically your tunable color is a networked system for commercial applications. This slide shows an overview of control types relative to each dynamic lighting type. There's several things to note on this. Starting on the left with content or scenes and getting the message to the luminaires on the right, there are many different control protocols, languages, and methods used for creation of control content, shows, and scenes. Note the arrows and the line types between the content and the luminaires, or the sensors if the sensors are on the system. The arrows represent single data transfer and in what direction the information is being transferred. So starting at the top with dim to white option, 0 to 10 volt phase cut, and then marching through the different types of control systems that are out there down to Bluetooth, Zigbee, and Wi-Fi. Starting on the left, if you've got your content or your scene and you're wanting to get that communication over to your luminaire, starting at the top, you have a straight line communication going from scene to luminaire. So the content says, hey, I want this light to dim, sends the message across a 0 to 10 volts for your dim to warm, and then the luminaire reacts. Same with the tunable white when you're controlling the scenes via 2 channels. You're just basically controlling the 2 channels of the 0 to 10, and that's a one-way communication. When you start talking about DMX or RDM, Dolly, and any proprietary system, it's 2-way communication. So from your content side, it says, hey, light, I want you to turn this color, or I want you to do this thing. Sends the communication across to the light says, copy that, Ghost Rider, and sends the communication back to the controller that says, hey, I'm there. PoE is a little bit different, where you have your content show sending a signal over to the luminaire acts, sends it back, but it's a constant communication back and forth between the two when it comes to the PoE side. You're also sending, depending on the level, you're also sending power designation, or you're sending control signal as well. And then with Bluetooth and Zigbee, the reason why the communication is back and forth as well, but the reason why it's a dash line is because it's all wireless. So all of the solid lines indicate wired connectivity, and the dash line is wireless connectivity. Learning objective number 4, become aware of the regulations, standards, and customer requests that are driving adoption. So one of the things that we found over the last 10 years in the development of LEDs as our new lamp technology, as new technologies provide the specification and design communities with new tools, several industry governing organizations are newly formed or adopted to new technologies with best practices recommendations and standards. We're going to take a look at 4 different governing bodies that are starting to think about and starting to existing governing bodies that are looking at the new dynamic requirements, and then any new ones as well. So IES recommended practices, recommendations, and standards. IES has prepared a publication that will be published called Recommended Practice for Supporting the Physiological and Behavioral Effects of Lighting in Daytime Environments. While we're still waiting the release of this official document detailing the recommended practice from IES, we do know that they've taken exception to UL recommended practice 24480, citing the lack of peer review and the need for more immersion metrics for measuring circadian environment. And then this little blurb down here is the IES official position statement. I'll give you a minute to read through that. But one of the things that is happening right now that's just recently in the last 6 months, one of the researchers over at the LRC has gotten a $5 million grant to be able to do more research on circadian rhythms and how lighting can impact that. So I think in the future, we're going to see a lot more studies coming out from researchers that IES has the capability to be able to make recommendations or to utilize for main practices. Lighting Design Consortium, the DLC, effective 3/26 of 2018, the DLC provided a category for color tunable products to be evaluated and submitted for approval to the QPL list. So the DLC has defined 2 subcategories within tunable color. The first subcategory is white tunable products. White tunable products have a control signal specifically for adjusting CCT while maintaining nominally constant lumen output. These products may include a second independent dimming control. White tunable products include both white products that combine the output of 2 LED primaries, that's the 3000K or 5000K, and anything in between, and products with 3 or more white and or RGB LED primaries, that's your 5-channel, 3-channel scenario, so long as they produce white light as characterized above in response to their control signal. So the DLC has gone in and defined all of these so that then manufacturers can comply with them and get listed on the QPL list. Warm dimming products have a single input which controls both color temperature and light output, lowering the values of both concurrently, most typically to mimic the color temperature shift of incandescent dimming. Products that require an external control system to coordinate dimming and warming color temperature are not eligible. And then while the DLC does not seek to codify a metric by which to measure human-centric lighting, they are providing a means to submit products which may incorporate technologies aimed at satisfying the human-centric lighting design criteria for rebate purposes. Well Building Institute recommendations and standards. The Well Building Institute launches guidelines and metrics for circadian lighting design. WELL aims to provide a lighting environment that reduces circadian phase disruption, improves sleep quality, and positively impacts mood and productivity. The WELL system uses a variety of different features, including equivalent melanomic lux as the definitive design metrics in circadian lighting for determining light design in the built environment. And as such, their system differs slightly from other recommended practices. So in the WELL standard, there are different LOs that get complied with and are particular to lighting. And then UL, recommendations and standards. UL worked with the Lighting Research Center and Rensselaer Polytechnic Institute to develop a recommended practice for the specification, measurement, and application of lighting to support circadian entrainment of individuals in day work environments. CS is the metric to be used for establishing circadian entrainment lighting design, and the amount of light equivalent to that after 1 hour of exposure, capable of suppressing the production of melatonin at night by 30%, should be continuously available at the occupant's eye for a minimum of 2 hours during daytime. In very simple terms, this translates into a vertical illuminance at the eye of 350 lux for warm light sources and 200 lux for cool light sources. So as a summary, as researchers continue to study and report the impacts of the built environment on occupants' productivity, health, safety, and well-being, dynamic lighting considerations could become common recommended practices in lighting design. Being able to understand the luminaire level components necessary for a dynamic lighting system helps designers efficiently and thoughtfully develop their designs. For dynamic lighting systems to be successfully implemented, a general understanding of the proper control system needed is paramount. And industry standards, regulations, and building occupants' requests are creating demand for dynamic lighting solutions. And just as a final recap, we looked at all 4 types of dynamic lighting. We defined all 4 types. We looked through the different application and uses of all 4 types, and we talked about the control strategies of all 4 types. This is just a note of the resources that we used in development of this particular presentation. So if you want to research this a little bit more for your own edification, you're welcome to do that. And I would like to thank you for your time today. And this concludes the AIA Continuing Education Systems course. Thank you.